So, a two-stage video. We're going to first utilize counters and demonstrate their usage, and also the flashing lights. So, two FCs have been created on the left-hand side here. FC1, which we're going to do first. So we'll just activate and call it from our OB1 initially to get that over and done with. And then inside FC1, we're going to operate a simple counter operation to stop the conveyor. So first of all, we'll run a two-stage process to test and get the conveyor running. Using SR flip-flop to begin with, we'll label it with E, which is going to be our enable for the conveyor itself, and we're going to use SWG, the green push button, to activate, and then we're going to initially use SWR as our stop condition. So we're just going to run and test that. We've already downloaded previously to test all the devices are happy, so we're able to hopefully run along with this. We'll press our download for this section and update, so we should be able to go live and observe. So if we operate the green push button, we see that the latch has occurred, the SR flip-flop maintains the E, which is our enable command, and if we press the red push button, we see that it goes off. Nice and easy. What we want to do here is utilize a counter to get it to automatically shut off, and we're going to pick just 5 parts, or in this case 5 movements of a hand. So initially we need a counter. To get a counter in, you can place a blank box. CTU is the easiest counter to use right now, which is a count up counter. We call the options, place it in. We've got a couple of options here we need to facilitate. So the CU is the count up instruction. The count up instruction we're going to use is our S1 sensor. Although wired normally open, it is a 3-beam sensor, so it actually goes off to have the signal process as on. Therefore we use a normally closed, feeding into our count up. So every time a hand or workpiece goes via S1, we increase the count in the counter by 1. The reset for this, we didn't really talk about it yet, but what we'll just use is SWR. We're going to use the red push button anytime we press it. It's going to give us a stop feature for the conveyor, and also it will reset the counter at the same time. Preset value, we're going to go with 5. And then the bits on the right hand side, you don't have to use anything on the right hand side typically for most blocks. CV is the current value. It will be displayed what the current value is at. You'll see it live when it's on monitor mode. And Q is going to be activated when the counter reaches the preset value of 5. So you could control something here, and we'll just demonstrate it in this method. We'll use an M number, M0.0, currently labeled tag 1, and I want to go to my tags and just edit that and call that something along the lines of counter underscore done. Again, you're free to label it whatever you so wish. So basically when that counter reaches the value of the preset value, which is 5 in our example, it will activate this here M0.0. We can now use that signal to also reset this SR flip-flop. So to do that, by default, typically further down you go on these boxes, Siemens don't display, so what you can do is forcibly make it. We just click on the actual open command. We need the bypass and stick in another one, which is going to be an OR option, which is going to be that M0.0. So now we've still got our SWG starting and SWR stopping our conveyor, but now we have a secondary option for the counter being done, which is triggered from network 2, which happens after 5 counts of S1 being triggered, and that will then operate. And this is method 1 for how to use that. So let's get that downloaded and we'll test and demonstrate. So we load on to our PLC, we go on to monitor mode, see everything goes green thankfully, and we're able to observe. So just as a retest, we'll press SWG, the green push button, we see it goes active. We press the red, we see it obviously goes off. Our counter is currently sitting at 0, which is good, and then we're going to press green this time and simulate that the parts are running. So we're going to place either workpieces or a hand in. So there is the first one in, and you see the count goes to 1, 2, 3, 4, and on the fifth one we see the CTU, the counter becomes active. The preset value of 5 has now been reached within the current value, and it's actually just displayed up the top there above the DB1. That has activated this M0.0 as an output, which has now given us one possible option into the reset to turn it off. Now to get that to reset, we need to press SWR, which will lower the counter back to 0 via the reset, and is now obviously done away with this reset command going into it. We're now free to press the green push button again to restart the system, and it would obviously operate and work away. Okay, so pressing the red push button will just stop, and we'll show you a secondary method that we don't need to use additional pieces of memory. So we'll just go offline very quickly. We'll make a quick edit. We'll delete that out of the way, and we're going to rename this something slightly different. So what we can use is we can directly use the information from the counter. We just go into here and start typing the name of it. So there is our only available counter, IEC. Once we click on it, we get lots of different options, effectively what's all connected to it, and we are going to use the QU. Wee bit misleading, all these pieces of information are actually associated with a CTUD counter, which is for up and down. Although they're not displayed as part of it, they are physically part of it in the background that you don't see. So it's actually the QU appendage that you want to stick on here effectively. So we end up with IEC counter 0.QU. So it's now a bit which triggers via the counter when the QU becomes active. So we go to download and update that change that we made, and we go online once again, and we press the green push button, and we begin inserting parts or hands in this instance, and we have 1, 2, 3, 4 and 5, and we end up with exactly the same result. The difference being we've saved a piece of memory, and to be honest it's slightly easier in my personal opinion. Okay, so that is the first bit, which is going to be for counters. The second stage here is for flashing lights. We're going to do it in a completely separate program, so let's just go offline to begin with. So to get lights to flash, it is very simply the output that you wish to control. Let's go with the green light. So LG, which I have possibly not put on my tag table. Which I have not. Let's fix that. So LR and LG are Q0.5 and 0.6. So hopping back to my flashing lights, you see it's now been associated. You simply have whatever input condition you so want to have. Let's keep a very simple example. Let's go with SWG. So when SWG is operated, we want the light. And at the minute, this means it will go on solid. But to make it flash, all we need to do is one extra bit in the middle, and we need to activate our clock bits. The clock bits are currently already placed, as you can see, in between rung 13 and 21. You see each of them have a different frequency. For instance, the 2 Hz flashing bit is M20.3. Separate video showing how to set that up. So I will pick the M20.3, which is a 2 Hz flash. I'm going to change the program which I'm calling and get rid of the first one, and just now only call the second one, just for the demonstration. So now if I go to download on this one, and finish, we should hopefully be able to go live. You can see straight away the green flash is occurring at 20.3, which is at 2 Hz. So now when we operate our SWG and press and hold, the output is now flashing at the frequency by which the flashing bit is operational. Okay, so that's the very basic overview. Basically take your output that you wish to have a defined condition when it should happen, and you just place a flashing bit in between those two to operate at the required frequency you so wish. But let's combine it with the other one just to give a full example. So we are going to call both of them. We'll put FC2 down there, put FC1 in here, so we're now going to call both programs this time. And what we're going to say is when the counter is completely finished, we want to make the light flash, as basically as an indication that it's done its job. So when the counter is finished, that same IEC counter0.qu is a possible input for us to make something flash. We just put it on a separate network, pull in and normally open, again start typing your IEC, and it's going to be your QU, and that's going to operate the, let's just change it to the LR just for the sake of using a different one, and we'll choose a frequency by which it operates. So let's go with, and you can start typing for the clock frequency. If you come up here, let's go with 1 Hertz. So when that counter's finished, it's going to operate at 1 Hertz. So let's just test download that feature. So we load, and then we go back to our current other one, go online with it. And if we press the red, the counter had still maintained its value at 5, so press a red just to put it back to the start. We'll press our start this time to activate the machine. We'll put 5 workpieces in, and they start to see those going up. The counter is increasing, and when it reaches 5, we still proceed with the same one that we use the QU to stop the conveyor, and if we open up the other, we see when that is hit, its upper limit of 5, we're now operating as you can physically see with the red light. One other final example we're going to run with is we want to, when the counter has not yet reached 5, then we want to operate the red light permanently. Right. So in this instance, let's just press stop on that one. Lovely. We still want to control the same output this time, but we want separate conditions. We branch around, we have to make an OR condition. Now we want to use a compare. So we need to compare. So it is, we're going to say less than actually. So let's go with our less than command, less than or equal to, we'll go with. And when 1 is equal to the other. So we'll say when it's less than or equal to, we'll go 4. And the value of it is going to be the IEC counter, and it's going to be the CV, the current value for it. So if it's less than or equal to 4, we just want to bypass what is the flashing section of it and activate the red lamp permanently. So if the counter is less than 4, red light's on, and when it reaches 5, this section and the flashing light should take over and then put on the red light as a flash instead, as this bit here on the bottom left goes inactive. So again, we'll just download, and we go live with it as such, and we have the red light is on, as you can see, permanently. And then as we press start and start inserting the workpieces in, we've reached our 5. We've deactivated the compare function. We now have the top line now operational and controlling the light. And that is counters and flashing light examples.